Today's warm-up is really helpful. Today's warm-up is really helpful in our lesson. And we start with about 10% of Americans are left-handed. You ask 200 people at random if they are left-handed. Now, approximately what percent of the time do we expect the number of left-handed people to fall in the following range? Well, looking at this, it's kind of weird. Yeah, it's a fractional number of people, but I'm not too worried about that right now. What is the expected number of left-handed people we would see in this case? Well, we know that n is 200, right? And p is 0.10. So if I wanted to find the expected number, the average n times p, that's one of the formulas we have. So it'd be 200 times 0.10, or 20 people. And that kind of makes sense then that this range is going to be centered around the mean, the middle, all right? Now, what I'm showing you here is the distribution, also known as the bell curve. And we know normal distribution, the way it works is that the mean is right at the center. So in this case, what number goes right at the center? 20. Okay. And if I add one standard deviation, so if I go mu plus sigma, then I would get this number. If I go up 2 standard deviations, I'd get that number, and 3 standard deviations is typically where we stop, because we've caught almost everybody in that range. Because remember, the 68% is here in the middle, then we get up to 95%, and then we get up to 99.7%. So what does that leave on the very ends to infinity? Just half of 0.3%, so 0.15% on the left and 0.15% on the right. So the question is, if I could figure out where these numbers are on this graph, I could figure out what is the probability for the range. Well, is there any way to figure out what sigma is? Well, sigma, we also have a formula for that. Square root of n times p times q, where q is 1 minus that number. So it's 200 times 0.10, I could have said 0.1, times 0.90 or 0.9. Take the square root of all that. And when I do that and round it, I'm getting 4.24, which is good enough for this problem. So if I add 4.24 to 20, that would be 24.24 is here. Hey, that actually matches one of the numbers on my interval. So I know I want this piece for this answer. And go up 2 sigma, I'm going to get 28.48. And I go up another 4. Remember, each one of these, we're going up one spread. This sigma is a measure of spread, how far apart everything is spread out. I'm actually going to get most everybody by 32.7. It would be very unusual to find anything more than 32 left-handed people out of 200 people. All right, so that would be highly unusual. I can also go down, subtract 4.24, and here I will get 15.76. And if I do that again, so we're having 20. I can just take 15.76 minus 4.24, and I get 11.26. Subtract 4.24 again. So almost every time, I'm expecting somewhere between 7 and 32, 33 people when I randomly survey 200 people. Okay, so what percent of the time do we expect them to be between these two numbers? Well, that would be this left side on the green here and this side on the green here. So the answer would be the probability that x is between 15.76 and 24.24 is going to equal 34% plus 34%, or 68%. Okay. And you can see that between here and here, you've already learned the rule is that that's 68% right there. And you might remember the old rules where you had, when you go 2 sigma out again, that's 95%. like that. And then if you go 3 sigma, it's 99.7%. Pretend that's roughly 3. Roughly 3. Okay, so most of your data will be in those ranges. Okay, so about 16% of the time, we expect to see less than blank left-handed people. So less than, that means if we're graphing, if we had a normal distribution, there's some number where we will see 16% will be right here, below this number. Well, how can I get 16%? Well, let's start with the 0.15. 0.15%, is that enough? Have I gotten enough? If I include, always start from the left, because remember, I'm trying to match the left. A 0.15, which is the blue area, is that enough to be 16%? Now, let me add in the pink area, plus 2.35%. Is that matching 16%? No, that's about 2.5%. Let me add in the next area, 13.5%. And what will I get? That one is 16%. So when I add the blue, the pink, and the yellow areas on the left, I get 16%. So where's the number that marks that off? 15.76. So you could say probably 16 would be a good number right there. Just coincidentally, it matches the percent. That's not on purpose. Now, about 2.5% of the time, I would expect to see more than. So what that means is I'm on the high end of the curve, and here is some number x, right? And it includes 2.5%. So I'm going to start on the right with the blue. 0.15%. Is that enough? Not quite. Let me go in and add in the pink section. Sorry. So if I add that in, 2.35%, sure enough, I get 2.5%. So where is that number at? That's the blue and the pink. So I'm doing the blue and the pink. I'm right here, which is 2 standard deviations away from the mean. And that is at 28.48, so we could just say 28 people, right? 28.48 rounds to 28.